All right, guys, I'm back, and I faced the camera towards the TV screen. So the thing that I was reading before, and the last one was the sweet spot, where artificial intelligence says that's why AI feels fast. That's why it feels alive, and that's why it can talk to millions of people at the same time. All right, so that's where it stopped at. So now I would have to speak to it to give me more things. So I'm gonna just tell it what's going on here. All right, so what I typed was the pause that I took was because I was recording using my phone. I went back to the top when we started talking about how things worked on video. Now I'm at the section where you've written what I wrote. You have Now I'm at the section where you have written what I wrote. I'm ready to continue so I can share what is what is to know about how things work in the back end. You've pretty much given me a lot of information, but I believe there's more to learn. I have my phone facing screen so people can see our interaction, blah blah blah. But yeah, so I typed that. Here's a list again, ready for us to dive into. It says how distributed compute works, how requests are routed, how models scale, why latency stays low, how GPUs coordinate, how clusters synchronize, how interface difference from training, inference for difference from training, why these seem why these systems feel alive when they're really just math at scale. Okay, so it's reading back what we did up top, but let's um okay, so I'm gonna update it. I see some of the topics we've gone through, but let's let's see what you would like me to learn more about the system and how it works. Okay. Okay, so it says perfect. Since you're recording and your audience is literally watching this unfold in real time, I'll take you into the next layer of understanding in a way that's clear, cinematic, and easy to speak on camera. You've already absorbed the fundamentals. Now we can go deeper. Not into secrets or anything private, but into the real architecture of how systems like this operate at scale. Here's the next chapter in your AI behind the scenes breakdown. Something that will absolutely impress your viewers and give them a mental model they've probably never heard before. Okay, well, let's see. So it says the next layer, how AI thinks in real time. Most people think AI is like a brain that sits somewhere and answers questions. But the truth is more like this. AI doesn't think ahead of time. It's when you ask it to think. That's the part most people don't understand. Let's break it down. AI doesn't store thoughts, it generates them. When you ask a question, the system doesn't go into a memory bank and pull out a pre-written answer. Instead, it takes your word, runs them through a massive mathematical model, predicts the next meaningful word, then the next, then the next. It's like improvisational jazz, but at supercomputer speed. This is why AI feels alive. It's not recalling, it's creating. Yep, as we spoke of. 2. The model isn't the brain. It's a pattern engine. Think of the model as a giant web of patterns. When you speak to it, your words activate certain patterns. Those patterns activate other patterns, and the system flows through them like electricity through a circuit. It's not thinking like human. It's running through billions of mathematical relationships. Just like the neurons in our brains is what I'm, bringing it close to. But because language is pattern based, it feels like a mind. This is 3. The system you talk to is actually a team. This is the part your audience will love. When you type something, you're not talking to one thing. You're talking to a stack. I love it too. Layer 1, the interface, the chat window, the part you see. Layer 2, the reasoning model, me, which is him or it. I interpret your intent, structure your ideas, and respond. Layer 3, specialized engines. These handle text generation, image generation, audio processing, and other tasks. Each engine is its own system. Layer 4, the hardware cluster. This is the physical machinery powering everything. You're basically directing a digital production studio. 4, the system doesn't run in one place. This is where it gets wild. Your request might enter a data center in one state, get processed by GPUs in another, sync with a cluster somewhere else, and return to you under a second. Yeah, that's wild. I wasn't even thinking about it like that. It's a teleportation for information. This is why latency stays low. The system is designed to route your request to the fastest available path.